Hey, welcome back to Mr. PLs with Precal. This is Unit 3, Topic 1, Lesson number 3. Once again, getting into trigonometry. So, tangent is 12 over 5, so that would be opposite over adjacent, so that's opposite over adjacent. Figure out this missing side length. Well, it's a 5, 12, 13, but if I didn't know that, it'd be 5 squared, which is 25, plus 12 squared, which is 144, equals c squared. So this adds up to 169, and square root of 169 is 13. All right, so now I've got sine is opposite over hypotenuse, 12 over 13. Cosine is 5 over 13. Tangent would be opposite over adjacent, which is 12 over 5. And then cosecant is the reciprocal of sine, which would be 13 over 12. Secant is the reciprocal of cosine, so 13 over 5. And cotangent is the reciprocal of tangent, so that's 5 over 12. All right, so jumping right in. So which trig functions are positive in which quadrant? So we're talking about, well, if I make a triangle like this, okay, so if it happens to be 4, 3, and 5, now I know I didn't make it exactly that, but that doesn't really matter. If I'm going to do sine, that would be opposite over hypotenuse. That'd be positive over positive, which is a positive. So sine is always positive in quadrant 1. Cosine would be a positive over a positive, so that cosine is also a positive in quadrant 1. Tangent would be a positive over a positive, so that's also positive in quadrant 1. So anything in quadrant 1, so if you pick any point in quadrant 1, it's always going to be a positive because this is a positive positive. So it's always got a positive x and a positive y. And which means that the reciprocals obviously are still positive. Positive over positive was still going to be a positive as well. So quadrant 1 is positive in all 4 quadrants. I'm sorry. Let me say that again. So quadrant 1 is positive for all 6 trig functions. If I go to quadrant 2 and I make the exact same triangle, and I use this as theta instead of this, because remember theta is the distance from the terminal ray, which will be here, in the x-axis. So that would be negative 4 and 3 and 5, because remember I'm going left, which would be negative, and up is 3. So opposites over hypotenuse. So sine is positive in quadrant 2. Cosine would not be, because negative 4 over 5 would be negative. And tangent would also be negative because opposite over adjacent would be negative, positive over negative. Which means cosecant would also be positive in quadrant 2. If I make the exact same reference angle here, so that's negative 4 and negative 3 here, okay, so sine is negative because that would be opposite over hypotenuse, negative over positive. Cosine would be negative 4 over positive 5, so that's also negative. Tangent would be positive, though, because negative 3 over negative 4 is positive. So tangent is positive in quadrant 3, which means cotangent is also positive in quadrant 3. And then last but not least, if this is 4, negative 3, and this is also 5, so the only one that's going to be positive is cosine. Cosine would be adjacent over hypotenuse. So that's going to be positive. So this is quadrant 4. And then so is this. All right, so which means that only all of them are positive in quadrant 1. Only sine is positive in quadrant 2. And only tangent in quadrant 3. And only cosine in quadrant 4. So you probably have learned all. There is some acronyms to remember this, like all, so this is S, this is T, this is C. All students take calculus, or all students take calculus is one way to remind yourself of which one is the positive one. All right, so which quadrant is being described? It says cosine of theta is greater than 0. So cosine being greater than 0 means I'm looking for when it's positive. There's only 2 quadrants that make cosine positive. That would be 1 and 4. So I'm going to put 1 and 4 up above so I don't have to remember it. Tangent being negative, meaning less than 0. Tangent is only less than 0. It's positive in these 2 quadrants, so it's negative in these 2 quadrants. That would be quadrants 2 and 4. Now, clearly, the answer is quadrant 4 because it's the only one that meets both criteria. Sine of theta is less than 0, meaning it's negative. Sine is only negative in the bottom 2 quadrants, so that'd be 3 and 4. Cotangent, so keep in mind cotangent is the same as tangent, so it's positive in these 2 quadrants. That would be 1 and 3. You gotta be careful because I'm looking for positive, so you always gotta look at the sign. The only one that overlaps here is 3 is your answer. Cosecant, remember, is the same as sine. Sine being negative. The only 2 places sine is negative is in 3 and 4. And cosine of theta is negative. Cosine is negative in these two quadrants. That would be 2 and 3. And then the only overlap here is 3. All right. So now we're going to be talking about converting radians to degrees, and I got my calculator handy. So you remember when you did back in like geometry, you learned that pi times diameter, diameter times pi is the distance around the circle, which means 2 times pi times radius, which in this case is going to be 1. 2 times pi times the radius is always the distance all the way around. But if we make the radius 1, then it's really just 2 times pi times 1, which is really just times 2 pi. So if the radius is 1, then we know it's 2 pi is the distance all the way around the circle. So it's 2 pi radians, which is give or take about 6.3 radians. 2 times pi. Keep in mind, pi is irrational, 3.14. So it's about 6 radians, a little bit more than 6 radians. So therefore, 1 radian is equal to 180 divided by pi degrees. But 1 degree is equal to pi divided by 180 radians. So that's pi radians. Okay, so if you don't know what a radian is simply an equilateral triangle, although an arc is one of the sides, so it's not really a triangle. So if the radius is 1 this direction, the radius is always going to be the same direction, the same in the other direction, so that's 1 and 1 here, and then 1 radian means that it's the distance of that arc if it completes. This is also 1. So if the distance from here to here along the arc, keep in mind it's not a straight line, has to be exactly the same as the 2 radii. All right, so to solve these questions, you're just going to multiply this side by pi over 180. So you do 315 times pi is 315 pi. Divide that by 180. Now I'm going to use my graphing calculator to do this a little bit easier. I'm going to put 315 divided by 180, but okay, I got to turn my phone on. I got to turn the calculator on. 315 divided by 180, but I'm not going to press enter. I'm just going to leave it right there, and I'm going to press math, enter, enter, and then what it does is it simplifies it for you down to 7/4. So that's 7 pi over 4. Well, that's give or take about 21. It's almost about 21, 22 divided by 4, whatever that ends up being. But I'm going to leave it like this because that's a precise answer. I'm not going to round it. Even if it's negative, you do the exact same process. So that'd be negative 225 pi over 180. Forget about the pi for a moment and just focus on simplifying the fraction. So it's 225 divided by 180, math, enter, enter, and I get 5/4. So that's negative 5 pi over 4. Now, what if I'm doing it the other way around? Then I'm going to multiply it by 180 over pi. Now, keep in mind, 180 degrees over pi radians is the same thing, because 180 degrees is halfway around a circle. Pi radians, 3.14, is halfway around a circle, because 2 pi is all the way around a circle. So I'm really just multiplying it by 1. I'm not changing anything. I'm just changing radians into degrees, because I'm going to get rid of the pi's. So I'm going to do 5 times 180, which gives me 900, and then divide that by 4. Okay, so it's 900 pi technically, because 5 pi times 180 is 900 pi. The pi's cancel each other out, and I divide that by 4, and I get 225 degrees. Because it was 5 times 180 degrees was 900 degrees. Remember, you do the multiplication of the units as well. Multiply by 180 over pi, so that's degrees. Negative 3 times 180 gives me 540 pi degrees, 540 degrees pi, over 2 pi, but the pi's cancel out. Anything divided by itself is 1. Divided by 2 gives me 270 degrees. And you do the exact same for all the rest of the questions. All right, I'm going to skip that. Name 2 coterminal angles. Now, before I get into this, remember what a coterminal angle is. So if we have an angle like this as our reference angle, it's 30 degrees. If I go all the way around 360 degrees and go that 30 degrees more, which will be 390 degrees, they will terminate in the exact same place. So instead of going 30 degrees and you go 360 degrees more, you're going to end up in the exact same place. Same thing if you subtracted 360 degrees, you would end up in the exact same place. So that's what I'm literally going to do. I'm going to add 1 full circle and I get 860 degrees. Sine of 860 is exactly the same answer as sine of 500 because they literally terminate in the exact same place. The exact same quadrant, the exact same everything. Sine, cosine, tangent, all of their trig functions will be the exact same answer because it's a coterminal angle. Now, if I want to go negative, I would just simply subtract, and then that's going to give me 140 degrees. Now, what if, it would be the same for this one, 360, even though it's negative, so it's going to be a 300-degree angle is the same. 300 degrees is like here, is the same as negative 60, which is like that. And if I want to subtract, that would just negative 60 minus 360. Negative 60 minus 360, which gives me negative 420 degrees. Same thing. Now, over here, when you have radians, you want to add one full circle. That's like 2 pi. 2 pi is, remember, all the way around the circle. When it's a unit circle, that is, of course. But I cannot add things unless they have the same denominator, so I'm going to put divide by 3. But if I do that, I have to compensate. I have to put 6 pi on top because I multiply by 3. If I divide this by 3, then I have to also multiply the top by 3. Now I can add them together. I get 26 pi over 3. And then to subtract, that's easy because I already have, minus 6 pi over 3. 20 pi minus 6 pi ends up being 14 pi over 3. All right, so I am limited on top. Oh, you know what? I'm going to do one more. So let's see. Add 2 pi over 6. This becomes a 12. Add them together, you get 19 pi over 6. Subtract 7 minus 12 gives you negative 5 pi over 6. That would be coterminal as well, but it's 360 degrees backwards, clockwise. All right, last but not least, let's talk about the unit circle. I'm going to go more in depth in this in the next video. 360 degrees all the way around is 2 pi, so that matches here. Let me move myself. So a halfway around would be pi. That's 180 degrees. There. And halfway to half would be 1/2 of pi, so pi over 2 would be 90 degrees. There. So that's 1/2 pi, 2/2 pi, 3/2 pi, and then 4/2 pi. So 3/2 pi is really 270 degrees. That's there. All right, so now if I want to go halfway, that's 45 degrees, and I don't think that, yes, it is one of the choices. So that's 1/2 of a half, which is pi over 4. And pi over 4 is here. There we go. 1/4, 2/4, 3/4 pi, 4/4, 5/4 pi, 6/4, 7/4 pi. All right, to any of those? No, none of those were there. So 30, 60, 90, 120, 150, 180. So you'll notice that if pi is halfway around, that every 30 degrees, if this is 30, this is 60, this is 90. So it takes 6 of those 30 degrees. 6 times 30 is 180. So every 30 degrees is 1/6 of pi. So this is pi over 6. 30 degrees. Pi over 6. This is 2/6 pi. This is 3. No. Sorry. This is 1/6 pi, 2/6 pi, or 2/6 pi is the same thing as 1/3. And I think I just made it in my time limit. All right. Thanks again for watching, and have a wonderful day.